In section 1.6, we're going to be studying absolute value equations and inequalities, and our objective is to write and solve equations and inequalities involving absolute values. In this first video, we're just going to work with the equations, and in video 2, we'll work on the inequalities. Let's begin our discussion with some definitions. Let's first of all look at the definition of absolute value. We know that absolute value is the distance that a number is from zero. Now later we'll go into a more technical definition of that in terms of a function, but for now that's all we need to know. Extraneous solutions, those are answers to our problem that do not make our equation true. Now it's not that you will have done anything wrong mathematically, but when you go back to check those values, you'll find that they're not making your equation true. And I would strongly suggest that you check these. Notice that the term extraneous starts with the word extra. So that's what this means. We're getting some extra solutions that don't really make our equation true. Now let's go ahead and solve a few equations. Say we have that the absolute value of x is equal to 3. Well, what we're saying is that the distance from 0 has to be equal to 3. But we know that that happens twice, when x is 3 or when x is negative 3. So one of the things we need to realize is that every absolute value problem we're going to work with is actually going to result in us having two different problems to work. So let's look at the next one. 2x plus 4, the absolute value of that is equal to 12. Well, what that means is that 2x plus 4 could have given me 12, so that when I took the absolute value, I got 12. Or 2x plus 4 could have given me negative 12, so that if I take the absolute value of both sides, I still get positive 12. So now let's solve those two equations. So if I subtract 4 from my first one, I get that 2x is equal to 8 divided by 2, and x is 4. On my second equation, now it's really important that once you get the first value, you do not automatically assume that the other value is the opposite of that. That only works when we have an equation like this, where an absolute value is equal to a number. In this case, you're going to see we do not get negative 4 for the other solution. So if I subtract 4, I get 2x is negative 16, and divide by 2, and x would be equal to negative 8. So my two solutions for right now would be 4 and negative 8, but I need to test those to make sure that neither of those are extraneous. So substitute in very quickly. If I put 4 back into this original problem, 2 times 4 would be 8. 8 plus 4 is 12, and the absolute value of 12 is 12. Put in negative 8. 2 times negative 8 would be negative 16, plus 4 would be negative 12. The absolute value of that would be 12. So both of those are our solutions. Now in the next case, we have our absolute value being added and subtracted and multiplied with other values. Before we can set up our two equations like we did here, we need to first of all get the absolute value by itself. So let's start by subtracting off the 3, and that's going to give me 2. Absolute value of x plus 9 is equal to 4. Then we'll divide by 2 and get that the absolute value of x plus 9 is equal to 2. Now I can rewrite my two equations. So x plus 9 would have either given me 2, or x plus 9 could have given me negative 2. So again, once I take the absolute value of both sides of that, I would get back that x plus 9 was equal to 2. So solving this first equation, subtract 9, x is equal to negative 7. On the next equation, if I subtract 9, I get x is equal to negative 11. So it looks like my two solutions are negative 7 and negative 11. But now let's check those. If I put negative 7 back into this, negative 7 plus 9 would be negative 2. The absolute value of that would be positive 2. Times 2 would be 4, and 4 plus 3 would be 7. So that one works. If I put in negative 11 plus 9 is negative 2. The absolute value of that would be 2. 2 times 2 would be 4, plus 3 would be 7. And so that one works. So both of those are our solutions. All right, let's finish up with one more problem. So we have the absolute value of 5x minus 2 is equal to 7x plus 14. Since our absolute value is by itself, we can go ahead and write our two problems. So 5x minus 2 would be equal to 7x plus 14, and 5x minus 2 would equal negative 7x plus 14. So if we solve this first equation, I'm going to subtract a 5x from both sides. Then I'm going to subtract a 14 from both sides. Divide by 2. X is negative 8. Now on the other equation, I'm going to distribute first the negative through and get negative 7x minus 14. I'm going to add a 7x and get 12x minus 2 is equal to negative 14. Then add 2, and 12x would equal negative 12, and divide by 12, and x is negative 1. Now the last thing I need to do is just check to see if either of these are extraneous roots. So if I put in negative 8, 5 times negative 8 would be negative 40, minus 2 would be negative 42, and the absolute value of that would be 42. So on one side I've got 42. On the other side, if I do 7 times negative 8, that's negative 56, plus 14 is negative 42. So that's not true. There's an extraneous root. Now if I put negative 1 in, 5 times negative 1 would be negative 5, minus 2 would be negative 7, but then the absolute value of that would be 7. And on the other side, I have 7 times negative 1 is negative 7, plus 14, which is positive 7. So in this case, we have one solution.